July 4th, 1943. Major Wilhelm Schmoltz peered through his binoculars into the pre-dawn darkness from an advanced observation post 3 kilometers north of Ponieri Station. For 2 months, the German Ninth Army had been preparing for Operation Citadel. Schmoltz commanded a battalion of the 290th Infantry Division, positioned in the northern pincer of what would become the largest tank battle in history. His men occupied trenches reinforced with logs and sandbags. Behind them, Tiger tanks and Ferdinand tank destroyers waited in camouflage positions. Artillery batteries had registered their targets days earlier. Everything was ready for the assault that would begin in less than 3 hours. Schmoltz had fought in Poland, France, and for 2 years on the Eastern Front. He understood war. He knew how artillery sounded, how aerial bombardment felt, what it meant when the ground trembled from distant explosions. What happened at 0430 hours that July morning was something entirely different. The horizon erupted in light. Not the scattered flashes of conventional artillery, but walls of fire that seemed to ignite the sky itself. Then came the sound. Not the whistle of incoming shells, but a deafening roar unlike anything Schmoltz had ever heard. Hundreds of projectiles arced overhead, leaving trails of smoke and sparks. They fell in waves, detonating over German positions with volcanic fury that turned fortified strong points into craters filled with burning debris. The bombardment lasted 20 minutes. When it ended, Schmoltz's battalion had ceased to exist as an effective combat unit. 2 companies had vanished. Survivors stumbled through smoke so dense it blocked the sunrise, calling for medics who were mostly also dead. Schmoltz would later write in his report that the weapon that destroyed his battalion was unlike any artillery system Germany possessed or understood. Soviet forces called it Katyusha. German soldiers who survived called it Stalin's organ because of the sound the rockets made in flight. By the end of the Battle of Kursk, this weapon would be responsible for an estimated 680,000 German casualties, killed, wounded, or missing. But on that July morning, most German commanders still didn't understand what they were facing. Part 1. Born from Desperation. The Crisis of 1941. The weapon that devastated Major Schmoltz's battalion emerged from Soviet desperation, not Soviet innovation. In June 1941, when Germany invaded the Soviet Union, the Red Army possessed approximately 60,000 artillery pieces of various types. By December 1941, Soviet forces had lost more than 30,000 of those guns, either destroyed in combat or captured intact when German armor encircled entire armies. Traditional artillery required precision manufacturing. Each gun barrel needed to be rifled to exact specifications. Breech mechanisms required machined parts that could withstand thousands of firings. Recoil systems needed hydraulic cylinders manufactured to strict tolerances. And each artillery piece required a trained crew of 6 to 8 men who knew how to calculate firing solutions, adjust for wind and temperature, and maintain mechanical systems in combat conditions. The Soviet Union in late 1941 could not replace 30,000 pieces of conventional artillery. German bombing had destroyed factories. Skilled machinists had been killed or captured. Raw materials were scarce. The rocket solution. But Soviet engineers recognized that rockets didn't require rifled barrels or complex recoil systems. A rocket was essentially a tube filled with propellant and a warhead. It could be launched from a simple rail. The rocket motor provided thrust, fins provided stability. No precision machining required. The concept wasn't new. Soviet engineers had been experimenting with solid-fuel rockets since the early 1930s. By 1938, they had developed the RS-82 82mm rocket for use in ground attack aircraft. This rocket used a solid propellant motor and carried a high-explosive fragmentation warhead. It was cheap to produce and reasonably effective against ground targets when fired from low-flying aircraft. In 1939, Soviet artillery officer Ivan Gavai proposed mounting these aviation rockets on ground launchers. The idea seemed impractical to many senior officers. Rockets were inherently inaccurate. They lacked the range and precision of tube artillery. Why would the Red Army want imprecise weapons when precise weapons existed? Devay argued that precision didn't matter if you could saturate an entire area with explosives. A single rocket might miss its target, but 16 rockets fired simultaneously would cover an area the size of a football field with fragmentation and blast. And because rockets didn't require a recoil system, multiple launch tubes could be mounted on a single vehicle. You could create a saturation bombardment with weapons that cost a fraction of conventional artillery. Testing and deployment. The Soviet Weapons Testing Center in Leningrad conducted trials in late 1939. Engineers mounted aviation rockets on modified truck chassis. The results confirmed Gavai's theory. Individual rockets were wildly inaccurate, but when fired in salvos, they created area effects that conventional artillery couldn't match. The rockets spread in a roughly circular pattern. Everything within that circle was destroyed. In June 1941, just weeks before the German invasion, the Soviet High Command authorized limited production of what they designated the BM-13 rocket launcher. BM stood for Boyevaya Mashina, or combat vehicle. The 13 indicated the caliber in centimeters. Each launcher consisted of 16 guide rails mounted on the back of a ZIS-6 truck. Each rail held an M13 rocket, weighing 42 kilograms and carrying a 4.9 kilogram high-explosive warhead.
The first BM-13 battery consisted of 7 trucks with 16 rockets each, 112 rockets total per battery. The unit was designated Experimental Battery No. 1 and commanded by Captain Ivan Flyarov. First Blood, Orsha Station. On July 14, 1941, this battery received orders to deploy to the front near Smolensk, where German forces were advancing toward Moscow. At 19:15 hours that day, Flyarov's battery fired its first combat salvo against the German-held railway station at Orsha. 112 rockets were launched in 7 seconds. The complete salvo took less time to fire than it would take a single artillery battery to fire 1 shell. German forces at Orsha Station had no warning. They heard no preliminary artillery fire. They saw no muzzle flashes indicating gun positions. Suddenly, the sky filled with screaming projectiles, leaving smoke trails. The station exploded. Fuel tanks ignited. Ammunition trucks detonated. German soldiers who survived described the sensation of the earth itself opening to swallow them. The psychological effect exceeded the physical damage. German troops were veterans. They had endured artillery bombardment in Poland and France. They understood that conventional artillery fired in predictable patterns. You heard shells coming, you sought cover, you waited for the bombardment to end. But rocket salvos arrived without warning and ended before anyone could react. The sound was terrifying. The rockets shrieked in flight, creating a distinctive howling noise that German soldiers compared to church organs, hence the nickname Stalin's organ. Captain Flyarov's battery fired all its rockets and immediately withdrew. This was critical. Traditional artillery revealed its position with muzzle flash and sound. Counter-battery fire could destroy artillery positions within minutes, but rocket launchers could fire and disappear before German observers located them. The trucks were mobile. They could drive to a firing position, launch their complete salvo in seconds, and vanish before German counter-battery radar traced the trajectory back to the launch point. Part 2. Mass Production and the Mathematics of War. Industrial Simplicity. The German General Staff near Orsha filed reports describing a new Soviet weapon of unknown type. Initial assessments suggested it might be some sort of mortar or modified anti-aircraft rocket. German intelligence designated it as a multiple rocket launcher system, but had no details on how it worked or how many the Soviets possessed. What German intelligence didn't know was that the Soviet Union had just begun mass production of the BM-13. The weapon's simplicity made rapid manufacturing possible. The launch rails were welded steel. The truck chassis was a standard commercial vehicle. The rockets themselves required no precision components. A single factory could produce hundreds of launchers per month using common industrial equipment and semi-skilled labor. By September 1941, the Soviet Union had produced over 600 BM-13 launchers. By December, that number exceeded 1,000, and production was accelerating. Factories in Leningrad, Moscow, and Voronezh converted assembly lines from civilian truck production to rocket launcher production. The rockets themselves were even simpler to manufacture. Soviet factories produced the M-13 rocket from stamped steel tubes filled with pressed propellant and fitted with a simple nose cone containing high explosive. No complex fuse mechanism, no precision machining required. Workers with minimal training could assemble rockets in quantities of thousands per day. Economic warfare. In contrast, manufacturing a single 76mm artillery shell required machining the shell casing, installing a precision fuse mechanism, and filling it with explosive under controlled conditions. Each shell cost more than twice what a rocket costs. Each shell took 5 times longer to produce. The economic mathematics were overwhelming. With the same industrial effort required to build one conventional artillery battery with 6 guns, the Soviet Union could build 10 rocket launcher batteries with 70 trucks carrying 1,120 rockets total. The weight of explosives delivered per minute wasn't even comparable. Rocket launchers delivered 50 times more explosive weight in the same time period. German forces discovered this mathematical reality during the defense of Moscow in December 1941. Soviet rocket launcher batteries supported counterattacks along the entire front. German positions that had withstood days of conventional artillery bombardment were annihilated in minutes by rocket salvos. The psychological effect was as significant as the physical destruction. German soldiers who had felt relatively safe in reinforced positions realized that no fortification could withstand saturation rocket fire. Captured German reports from this period described the rockets as Terrorwaffen, terror weapons, not because they were particularly accurate or sophisticated, but because they created a sense of helplessness. There was no defense against them. You couldn't hear them coming in time to take cover. You couldn't predict where they would fall. You could only endure the bombardment and hope to survive. Part 3. Kursk, the ultimate test. Operation Citadel. By mid-1942, German military intelligence had compiled substantial data on Soviet rocket launches. They knew the basic specifications. They had recovered unexploded rockets and examined them. German engineers understood that the technology was primitive but effective. The rockets used simple solid propellant, basic aerodynamic stabilization, and crude impact fuses. Any industrialized nation could build equivalent weapons. But Germany did not attempt to match Soviet rocket launcher production. This decision reflected fundamental differences in military doctrine and industrial capacity.
German artillery doctrine emphasized precision. German gunners took pride in their accuracy, hitting specific targets with minimum ammunition expenditure. The idea of saturating large areas with imprecise rockets seemed wasteful and inefficient to officers trained in traditional artillery methods. More importantly, Germany lacked the industrial capacity to mass-produce rocket launchers while simultaneously manufacturing tanks, aircraft, submarines, and conventional artillery.
German factories operated near maximum capacity, producing weapons that required skilled labor and precision components. Rocket launchers seemed a poor use of limited resources. The Soviets, by contrast, had embraced rocket launchers precisely because they required minimal precision manufacturing. Soviet industrial doctrine prioritized quantity over quality. Simple weapons produced in large numbers could achieve effects that sophisticated weapons in small numbers could not. This philosophical difference would manifest most dramatically at Kursk. German planning. German planning for Operation Citadel began in April 1943. The operation aimed to encircle and destroy Soviet forces in a massive salient that bulged into German-controlled territory near the city of Kursk. German intelligence estimated approximately 1 million Soviet troops defended the salient. Destroying this force would cripple Soviet offensive capability and potentially force a negotiated peace. Field Marshal Erich von Manstein commanded the southern pincer. Field Marshal Gunther von Klug commanded the northern pincer. Between them, they assembled nearly 750,000 German troops, 2,700 tanks, including the new Tiger and Panther models, and 2,000 aircraft. This represented the largest concentration of German combat power ever assembled for a single operation. The attack date was set for July 5, 1943. German forces would attack simultaneously from north and south, meeting somewhere near Kursk to close the pocket. Intelligence estimated the operation would last 1 week. Soviet preparation. The Soviets, however, knew the attack was coming. Soviet intelligence had penetrated German communications. British cryptographers at Bletchley Park had decoded Wehrmacht messages and passed the information to Moscow through the Lucy spy network. Soviet commanders knew not only that an attack was coming, but where it would strike and approximately when. Marshal Georgy Zhukov, commanding Soviet defenses, had 2 months to prepare. His strategy was simple but unprecedented in scale. Instead of meeting the German attack with mobile defense, Soviet forces would build fortified positions so deep and so heavily defended that German armor would be bled white before achieving any breakthrough. And the primary weapon for this defense would not be tanks or anti-tank guns. It would be massed rocket artillery, firing from pre-surveyed positions against pre-established target zones. Soviet engineers constructed 8 defensive belts across the entire Kursk salient, extending to a depth of 190 kilometers. Each belt contained anti-tank ditches, minefields, reinforced strong points, and camouflaged artillery positions. Behind these belts, Soviet forces positioned 300 rocket launcher batteries with over 3,000 individual launchers. Each battery was assigned specific fire zones. Surveyors had precisely mapped every square kilometer of the battlefield. When German forces entered these zones, rocket batteries would fire pre-calculated salvos that would saturate entire areas, regardless of where specific German units were located. The mathematics of annihilation. The operational mathematics were staggering. 3,000 launchers with 16 rockets each meant 48,000 rockets could be fired in a single salvo. With an average warhead weight of nearly 5 kilograms per rocket, that represent 240,000 kilograms of high explosive delivered in less than 10 seconds across dozens of square kilometers. No army in history had prepared such concentrated firepower for a defensive battle. German intelligence detected Soviet preparations. Aerial reconnaissance photographed defensive works. Captured Soviet prisoners described the fortifications. But German commanders did not fully comprehend what they faced. They understood the Soviets had strong defenses. They did not understand that those defenses were designed specifically to channel German forces into predetermined kill zones where rocket artillery would destroy them en masse. July 5, 1943. The storm breaks. On the night of July 4, 1943, German assault units moved to their final attack positions. Engineers cleared paths through Soviet minefields. Tank crews started their engines. artillery batteries prepared to fire preliminary bombardments. The attack would begin at 0430 hours on July 5th. But at 0420 hours, Soviet rocket batteries opened fire first. This was the bombardment Major William Schmoltz witnessed and barely survived. Soviet intelligence had precisely identified German assembly areas. Forward observers had watched German forces move into position during the previous night. When Soviet batteries fired, they weren't shooting at suspected targets. They were firing pre-calculated salvos at locations they knew German units were concentrated. The effect was catastrophic. German infantry battalions that were at full strength at midnight were reduced to company strength by dawn. Tank formations that had assembled for coordinated assaults were scattered and disorganized. Artillery batteries that should have been firing preparatory bombardments were destroyed before they could fire a single shell.
And the rocket bombardment was not a single salvo. It continued in waves. As soon as one battery emptied its rockets, trucks raced forward with reload racks. Within 30 minutes, the same battery could fire again. German forces had never experienced sustained rocket bombardment of this intensity. In previous battles, Soviet rocket launchers had been used sparingly, firing single salvos before withdrawing. At Kursk, the Soviets employed rocket artillery as the primary instrument of defensive fire, coordinated with conventional artillery, anti-tank guns, and close air support. The result was a defensive system that inflicted maximum casualties on attacking forces before they even reached Soviet positions. Part 4. The 48-hour analysis. Assessing the carnage. Major Schmalz's experience was replicated across dozens of German units along the northern and southern attack axes. German commanders filed reports describing weapon effects they had never seen before. Entire companies disappeared. Tank crews abandoned intact vehicles because sustained rocket fire had killed or wounded everyone nearby who could provide infantry support. Forward observers couldn't direct artillery fire because they were dead. Communication lines were cut. Command and control collapsed. By the end of the first day, German forces had advanced no more than 10 kilometers at any point. Casualties were staggering. The 9th Army in the north reported more than 20,000 casualties on July 5th alone. The 4th Panzer Army in the south reported similar losses. These were casualties before German forces had even engaged the main Soviet defensive lines. They were caused primarily by artillery and rocket fire in the approach zones. German High Command held emergency conferences on the night of July 5th. Field Marshal von Manstein argued the operation must continue. German forces had penetrated advanced Soviet defenses and were approaching the main belt. But Field Marshal von Klug reported that his northern forces had suffered such severe damage that further advance seemed impossible without reinforcements. Casualty rates were unsustainable. That night, Wehrmacht intelligence officers compiled reports from multiple units describing Soviet rocket artillery. For the first time, German commanders began to understand the scale of what they faced. Soviet forces weren't using rocket launchers as supplementary weapons. They had made rocket artillery the centerpiece of their defensive strategy. And they possessed enough launchers and enough ammunition to fire sustained bombardments for days. Technical analysis. This realization triggered urgent analysis. If Soviet rocket artillery could inflict such casualties on German forces attacking prepared defenses, then every future German offensive would face the same problem. Wehrmacht planners needed to understand exactly how the system worked, how many launchers the Soviets possessed, and whether Germany could develop equivalent capabilities or effective countermeasures. 2 officers were assigned to lead this analysis. Colonel General Kurt Zeitzler, Chief of the Army General Staff, ordered an immediate technical assessment. Major General Walter Wenck, commanding the operations staff of the 1st Panzer Army, was instructed to collect battlefield reports from units that had encountered rocket fire. They had 48 hours to provide answers. German commanders needed to know whether Operation Citadel should continue or be abandoned. The analysis began immediately. Intelligence officers examined captured Soviet documents, interrogated prisoners, and studied unexploded rockets recovered from the battlefield. What they discovered was both impressive and deeply troubling. The weapon revealed. The BM-13 Katyusha launcher was mechanically primitive. 16 steel rails welded to a truck bed. No hydraulic systems, no complex fire control mechanisms. Each rocket sat on a simple guide rail and was launched electrically. The entire system could be operated by a 5-man crew with minimal training. A competent welder could build a launcher in 3 days using standard truck components and basic steel stock. The rockets themselves were even simpler. Stamped steel tubes filled with pressed solid propellant, a basic impact fuse in the nose, stabilizing fins welded to the rear. Manufacturing required no precision machining, specialized equipment, or rare materials. Soviet factories were producing these rockets at rates exceeding 50,000 per month. Each rocket cost approximately 1/10 what a conventional artillery shell cost. A different philosophy of warfare. German engineers immediately recognized this represented a different philosophy of warfare. Traditional artillery achieved effects through precision. A skilled artillery crew could hit a specific building from 10 kilometers away. But training that crew took months. Building the gun required specialized factories. Producing ammunition required precision manufacturing. The Katyusha system sacrificed all precision in exchange for overwhelming volume. A single battery could deliver more explosive weight in 10 seconds than a battalion of conventional artillery could deliver in 10 minutes. The mathematics were damning. Germany had built its artillery doctrine around the 75mm field howitzer and the 150mm heavy howitzer. These were excellent weapons, precise and reliable, but they were also expensive and slow to produce. A single German artillery division possessed 144 guns. Those guns could fire perhaps 2,000 shells per hour under ideal conditions, delivering approximately 15 tons of explosive. A Soviet rocket launcher brigade with 72 BM-13 launchers could fire 1,152 rockets in a single salvo lasting 7 seconds, delivering approximately 35 tons of explosive. The brigade could reload and fire again in 20 minutes.
In 1 hour, that single brigade could deliver over 100 tons of explosive, nearly 7 times what an entire German artillery division could achieve. Strategic implications. Colonel General Zeitzler presented these findings to Hitler on July 10. The implications were clear. Soviet industry had found a way to convert industrial capacity directly into battlefield firepower without the lengthy training, complex logistics, or precision manufacturing that traditional weapons required. The Katyusha wasn't a better weapon than German artillery. It was a different category of weapon that changed the fundamental economics of firepower. Germany could build superior tanks, superior aircraft, superior artillery pieces. But if the Soviets could produce 10 rocket launchers for every piece of German artillery, quality advantages became irrelevant. Operational analysis. Major General Wenck's operational analysis was equally grim. German casualties at Kursk had reached catastrophic levels, not because Soviet defenses were impenetrable, but because rocket artillery had destroyed German units before they could deploy their combat power. German tactical doctrine assumed that infantry and armor could advance under covering artillery fire, but Soviet rocket bombardments were so intense that German forces couldn't maintain formation coherence during approach movements. Tank commanders reported that sustained rocket fire forced them to button up their vehicles, reducing visibility and situational awareness. Infantry that should have been covering the tanks was pinned down or killed. Combined arms coordination broke down. German units arrived at Soviet defensive lines already disorganized and exhausted, making them vulnerable to counterattacks by fresh Soviet reserves. Even more troubling, German forces had no effective countermeasures. Traditional counter-battery fire was ineffective because Katyusha launchers could fire and relocate within minutes. By the time German artillery calculated firing solutions, the Soviet launchers were gone. Air attacks were limited by Soviet air defenses and the sheer number of targets. Even if the Luftwaffe fighters destroyed a dozen launchers, the Soviets had hundreds more. The verdict. The 48-hour analysis reached conclusions that German high command didn't want to hear. The Red Army had developed a weapon system that leveraged Soviet industrial strengths while exploiting German weaknesses. Germany couldn't copy the Katyusha because German factories were already committed to producing precision weapons. Switching to mass production of simple rocket launchers would require retooling facilities and abandoning conventional artillery production. That was impossible while fighting a war on multiple fronts. More fundamentally, the Katyusha revealed that the Soviet Union had learned to fight differently. German doctrine emphasized quality, training, and tactical superiority. Soviet doctrine increasingly emphasized quantity, simplicity, and overwhelming material superiority. In this paradigm, the side that could deploy more firepower would win regardless of tactical skill.
Part 5. Aftermath and Legacy. The end of Operation Citadel. By July 12th, Operation Citadel was effectively over. German forces had advanced at most 35 kilometers into Soviet defenses. They had lost more than 50,000 killed and wounded. Over 300 tanks were destroyed or disabled. The offensive had failed to encircle Soviet forces or achieve any strategic objectives. Hitler ordered termination of the operation on July 13th. German casualties at Kursk ultimately reached an estimated 680,000 killed, wounded, or missing across the entire operation, including subsequent Soviet counteroffensives. While many factors contributed to this disaster, German after-action reports consistently identified Soviet rocket artillery as the decisive factor that broke German attacks before they could develop momentum. Lessons learned. The lessons of Kursk propagated through Wehrmacht planning for the remainder of the war. German forces never again attempted a major offensive operation on the Eastern Front. The understanding that Soviet industry could produce firepower at scales Germany couldn't match fundamentally altered strategic calculations. Victory was no longer possible. The only question was how long Germany could delay defeat. Soviet production of Katyusha launchers continued to accelerate. By the end of 1943, more than 3,000 launchers were in service. By 1945, that number exceeded 10,000. The Soviets also developed improved models, including the BM-31 with heavier rockets and the BM-8 with lighter rockets for different tactical applications. The basic concept remained unchanged: simple launchers, cheap rockets, overwhelming volume. Global impact. After the war, Soviet rocket artillery influenced military doctrine worldwide. Nations recognized that precision wasn't always necessary if saturation effects could be achieved. The multiple rocket launcher became standard equipment for armies globally. Modern systems like the American M270 MLRS and the Russian BM-30 Smerch trace their lineage directly to the Katyusha. The German generals who studied the Katyusha during those 48 hours at Kursk understood what they had discovered.
Soviet forces had found a way to convert industrial capacity directly into battlefield firepower without the lengthy training, complex logistics, or precision manufacturing that traditional weapons required. It wasn't elegant, it wasn't sophisticated, but it was devastatingly effective. Epilogue: The Survivor's Testimony. Major Wilhelm Schmaltz survived the war. In his memoirs, published in 1953, he wrote about that July morning when his battalion was destroyed. He described the rockets as something unlike anything in the German arsenal, weapons that seemed to embody Soviet military philosophy, crude, brutal, and produced in quantities that made quality irrelevant. He survived because he had been in an observation post slightly removed from his battalion's main position. Most of his men did not. The weapon that destroyed them cost the Soviet Union approximately 12,000 rubles per launcher to produce, roughly the cost of a single German infantry truck. Each rocket cost 30 rubles, approximately the price of a soldier's boots. For less than the cost of equipping a single German infantry battalion, the Soviets could build a rocket battery that would annihilate that entire battalion in 7 seconds. That was the reality German generals discovered during their 48-hour analysis at Kursk. The Soviets hadn't built a better weapon. They had changed the mathematics of war. And Germany, fighting with limited industrial capacity against enemies with virtually unlimited resources, could not win a war decided by mathematics.